Isn't it possible that 2 billion years ago we endured an act of cosmic catastrophe? In fact, the experts discovered that our Milky Way was actually still sporting a little sibling back then, and that when the Andromeda Galaxy came calling, the little sibling was torn completely apart and destroyed. Even putting aside this cataclysmic event, our galactic neighbor continues to shock our experts. It's probably not news to you that the Milky Way will hit Andromeda in another 4 billion years, but amazingly, the newest models paint a very different picture for that, and actually there is some hope that we will completely miss the encounter. You don't know this yet, but there's a cannibal living next door to you. Well, be careful. I'll tell you right now, before you start asking anyone you know if they eat properly, that this applies only to your galactic neighborhood. The Andromeda Galaxy is actually the closest sister of our Milky Way, but though it's still a proud distance of 2.5 million light-years, it's also the most remote human-visible object in the night sky that we can see with the naked eye. We shouldn't be surprised, really, as that's how big our neighboring galaxy is, a diameter of 200,000 light-years, almost double the diameter of our own Milky Way. Experts on the question of mass, however, sometimes come up with varying estimates. Andromeda has been thought to contain between about 700 billion solar masses to more than 2.5 trillion solar masses, while our home galaxy, while replete with about 1.5 billion solar masses. However, while the movements of fast Andromeda stars indicate that the two galactic associations have roughly equal mass, the issue of how much mass each contains remains a controversial question. However, what's not up for dispute now is that Andromeda has in fact devoured a good chunk of its current mass. At some point in the galaxy's history, it has collided with other galaxies many times over and then swallowed them. Credit for discovering this case of galactic cannibalism belongs to University of Michigan, in Ann Arbor's Eric Bell and Richard Duza. The experts had a background to the surprisingly metal-rich stars that lie dormant in the halo and in a huge stream of stars in Andromeda, which also resides in a galaxy that forms one of its admirers. Surprisingly, all the structures examined display characteristics that suggest common origin. At the same time, in deep space, they could be the leftovers from a galactic clash when the Milky Way's sister was swallowed by Andromeda. In fact, the answer to this question was yes. Well, the collision partner was by no means some puny dwarf galaxy at that time. It was, in detail, the third big player, M32P, in the local group, between Andromeda and the Milky Way. With around 25 billion solar masses, the galaxy was downright shocking that we couldn't see the existence of the Milky Way sister for so long, Duza says. But now we know. The determining scientists found that M32P had been pulled under Andromeda's gravitational clutches 5 billion years ago, setting the stage for a cosmic catastrophe, which was completed 3 billion years later. The reason for this, said Chanda, is because after the third largest galaxy in the local group was pulled apart and torn into its individual parts by the gravitational forces, it was finally completely destroyed and absorbed by Andromeda. As noted, the strikingly metal-rich stars are as traces of this cannibalistic feast still seen today. However, experts also said the dwarf galaxy, M32, which the galaxy under study was the interior of, had once been the center of the destroyed structure. M32, however, is an astronomical anomaly. It looks very much like an old classical elliptical galaxy at first, but the thing is, you can see countless young stars, and as incredible as it sounds, the thing is extremely compact. It followed that the tryst with Andromeda should have left most of the compact core of the galaxy largely undamaged. The study of the collision, however, also led to the opening of a completely new research line. Until now, it was believed that, with such massive galaxies, all collisions always conjured chaos in the large crash partner's stellar disk. And I can tell you that that was not the case with Andromeda, although M32P was incorporated without a trace. This devoured galaxy started a huge wave of star formation, during which 20% of its stellar mass was reformed, which means the Milky Way won't likely be crashed after all. That is the bottom line. Andromeda collided with M32P just as it has many other times. In addition, our neighboring galaxy has a significantly larger and more complex halo than the Milky Way, with one obvious implication, that it must have been in contact with other galaxies many times in the past. Accordingly, the researchers found globular clusters in the Andromeda's peripheral regions that are twisting at different rates and in two very different ways, one rotating perpendicularly and the other coaxially. Finally, astronomers conclude it has already endured two major bouts of cannibalistic events that, it is assumed, happened a few billion years apart. The first event may date back 10 billion years, while there is evidence of a second, when the sister of the Milky Way was swallowed, which may have taken place less than 1 billion years ago. Barring a disaster on the scale of a black hole, eating the Earth, thinking of our own galactic home, you have to ask, when Andromeda comes a-calling in a few billion years, what will happen to the Milky Way itself? But at least one would think so. However, this question is in reality clearly secondary. New models suggest, however, that the galaxies are almost certainly not about to collide. So how did it come to be, in the first place? And for a long time it has actually been considered certain that our galactic neighbor is heading towards us at 266 kilometers, and that the halos of the Milky Way and Andromeda that reach out so far have already touched. Taking into consideration the above, one has come to the opinion that at some very distant time, the two will fuse into Milkdromeda, a new elliptical galaxy, whose name is comprised of the beginning of the Milky Way and the beginning of the Andromeda. Not that this is a new idea, since the American astronomer Vesto Melvin Slipher had realized almost 100 years ago that Andromeda was on a collision course with the surrounding galaxies by noting the color shift of the light in the spectrum, from Andromeda towards blue. Critics of the predicted Andromeda-Milky Way collision argue that the two galaxies are not the only galaxies in their cosmic neighborhood, nor should we underestimate the effect of their other structures. Among the first and foremost such galaxies are the Large Magellanic Cloud and the Triangulum Galaxy, which, unlike their names, are also galaxies. In fact, more recent studies have re-evaluated the true masses of galaxies in the local group added to this. But how do all these factors play out when the Milky Way and Andromeda finally crash? And a team of experts from the University of Helsinki has just answered a question exactly like that, and that result is extremely surprising. To determine the masses, motions, and gravitational interactions of the four galaxies at play, the researchers used observational data from the Gaia and Hubble space telescopes. Then they put the information into a computer model, which ran through a series of potential scenarios, and lo and behold, if our galaxy and Andromeda aren't restrained by some external force, we'd encounter a nightmare head-on collision in almost half of all possible scenarios. The probability of a collision with the Triangulum Galaxy increases to 66% if we only consider the Triangulum Galaxy. After all, it will be headed right past Andromeda right before the big crash, eventually, adding yet more oomph to propel it in the direction of our home world. But if we add the Large Magellanic Cloud to the mix, things are not the same. Since it's going across the Andromeda-Milky Way collision course, it probably will redirect our home itself as we crash into Andromeda. All of this seems to suggest that the merger of the galaxies is not inevitable, in fact, with a 50% chance of it happening. So the probability of a collision is as great as the probability it won't. That makes it rather a galactic coin toss. But if the coin is actually merger, as the scientists suggest, rather than in around 4 billion years as was assumed, merger will happen in 8 billion years at the latest. But, in the same breath, the researchers caution that the last word on Milkdromeda has not been said. With uncertainties of the positions, masses, and motions of the galaxies under investigation still present, there is still lots of room for wildly different results. Experts. are waiting for the most up-to-date data from the Gaia Space Telescope in order to make even better predictions. These models have only been recently recalibrated, and future investigations will repeatedly refine calibration. We will eventually run out of fuel, and all of the galaxies in the local group will collide and merge, or at least according to current scientific theory. The question is whether there will be anyone around to view whatever happens. For example, by all means, the expected time to fusion of the worlds should be much longer than age of the universe itself multiple times. Luckily, the merge of the thumb into the subscribe button only takes a blink of an eye. We'll see you soon.